Hello everyone, in this video, I'm going to show to you how to derive the variance for discrete uniform distribution. In the derivation process, we need to use the probability mass function or PMF for this distribution, which is shown in here as just 1 over n. This n in here is a constant. The random variable for this distribution should have an integer value and should be between a to b. Now, if you're looking for a derivation where the value of the random variable is from 1 to n, that derivation is on another video and I provided the link in below description so you can check it out if you are interested. So we can now remove this. So the derivation in this video is where the value of the random variable is from a to b. Now for this n in here, it is a value of b minus a plus 1, where this b is this and a is this. Now aside from the probability mass function, in the derivation process, we need also to use the formula for the mean for this distribution, which is this. So now let us derive the variance. In general, the formula for the variance is expectation of x minus expectation of x and then squared. This x in here, same with this x in here, is the random variable. And we have another formula for this variance, and it is expectation of x squared minus the square of expectation of x. This expression in here can be derived from this expression if we expand this square term and do some algebra afterwards. Now for this expectation of x, it is same with this, equal to this, so we can use this in here. So it will become expectation of x squared minus square of this. Then for the expectation of x squared, let us evaluate this. For this expectation of x squared, in general for a discrete random variable, in here we have a discrete random variable. It is equal to summation of, we have here x squared, and then times its probability mass function or PMF, which is in this case this 1 over n. Then the random variable can have values from a to b, so we have here from x is equal to a until b. Now this 1 over n in here is a constant, so we can move it outside of this summation. And then let us do some transformation. Let y is equal to x minus a plus 1. So we're gonna transform this x to y, and then from here x will be equal to y, and then plus a, and then minus 1. Using this, we can simplify the evaluation of this expression. Let us substitute this for x in here. Then let us change this x to y using this. So we have here, we have this 1 over n in here, and then summation of, for x we have this, and then squared. And then it is from y is equal to, when x is equal to a, in here y is equal to a minus a plus 1 or just 1. And then until when x is equal to b, in here y is equal to b minus a plus 1. Now for this b minus a plus 1, it is same with this, it is equal to n. So we have in here, this b minus a plus 1 can be replaced by n. Then let us expand this square term here for y and a minus 1. So we have here 1 over n summation of square of y plus 2 times y times a minus 1, then plus square of a minus 1. This is from y is equal to 1 until n. Then let us distribute this summation for each term in here. So we have here 1 over n, then times summation of y squared from y equals to 1 to n plus in here these 2 and a minus 1 are constants, so we can move them outside of this summation. So we have here 2 times a minus 1, then summation of, we have here y from y is equal to 1 to n, and then plus summation of this. In here this a minus 1 squared is a constant, and we're summing it from y equals to 1 to n, or n times, so we have here n times this constant a minus 1 squared. Then for this summation in here, we have this is equal to, we have here when y is equal to 1 we have 1 squared, then plus when y is equal to 2 we have 2 squared, then plus when y is equal to 3 we have 3 squared, and then plus we have 4 squared, we have 5 squared, etc. until when y is equal to n we have n squared. Now for this series in here, from algebra or from discrete mathematics, the sum of the series in here has a formula of n times n plus 1 times 2n plus 1 over 6. And then for the summation of y in here, it is equal to, when y is equal to 1 we have 1, when y is equal to 2 we have 2, when y is equal to 3 we have 3, and then 4, and then 5, etc. until when y is equal to n we have n. And then from algebra, for this arithmetic series, it has a formula of n times n plus 1 over 2. Then for this summation of y squared, we have this, and for the summation of y, we have this. So now for the expectation of x squared, which is this, it is equal to, we have this 1 over n, then times, for this we have this, then plus 2 times a minus 1, then times this, which is this. Then plus this. Then from here, we can cancel out this 2 and 2. Then we have here a common factor n. So we can move out this n outside of the bracket. So we have here n. Then we can remove the n in here, n in here, and n in here. Then we have here n over n or 1. So we can cancel them out. So what we're left with are these. For these two, we have a common factor n plus 1. So we have here n plus 1. Then times, we can have here a common denominator of 6. So we have here 6. Then what we're left with in here is 2n plus 1. Then what we're left with in here is a minus 1. And then multiply by 6, we have 6a minus 6. So we have here 6a minus 6. And then in here we have plus square of a minus 1. Then in here we have plus 1 minus 6 or minus 5. So we have now the expectation of x squared. Now for the variance, it is expectation of x squared minus the square of this. So we have here variance is equal to expectation of x squared, which is this, two n plus 6a minus 5, then over 6, then plus this, then minus square of a plus b over 2. Now, in here, this is a difference of two squares of terms, and from algebra we know that the difference of squares of two terms can be factored out as a product of the sum of the two terms and the difference between the two terms. So let us apply this in here. For this we have for the sum we have a minus 1 plus a plus b over 2 and then for the difference it is a minus 1 minus a plus b over 2. Then in here and in here we can have a common denominator of 2. So we have here, for this we have 2 times a minus 1 or 2a minus 2, then plus a plus b. Then times, we have here 2, then 2 times a minus 1 is 2a minus 2, then minus a plus b, or minus a minus b. Then it is equal to, let us write b first, then 2a plus a is 3a, and then minus 2. Then we have here, let us combine both. We have here 2 times 2, or 4. Then for this we have negative b, then 2a minus a is a, then minus 2. Then let us multiply negative 1 for this, and also negative 1 for this. Negative 1 times negative 1 is 1, so they will not change the value of this, so it will be equal to, we have negative b minus 3a plus 2, then we have in here b minus a plus 2, and then over 4. Then for this b minus a plus 2, in here n is equal to b minus a plus 1, and if we add 1 on this n, we have b minus a plus 1 plus 1, or b minus a plus 2. So for b minus a plus 2, it is n plus 1. So in here, this b minus a plus 2 is n plus 1. So now we have this expression in here to be equal to this. So let us use this for this expression in here. So we have here variance is equal to, we have this, then plus this, which is this. So we have now for this 2, we have a common factor of n plus 1, so we have here n plus 1. Then let us have a common denominator of 12. Then 12 divided by 6 is 2, so we have here 4n plus 12a minus 10. And then plus, in here, 12 divided by 4 is 3. So we need to multiply this by 3. So we have here negative 3b. Then negative 9a. Then plus 6. Then for this n in here, it is b minus a plus 1. And for 4n, it is equal to 4 times this, or 4b minus 4a plus 4. So in here, this 4n will be 4b minus 4a plus 4. So now it is equal to n plus 1, then times, we have 4b minus 3b is b, then minus 4a plus 12a is plus 8a, and then minus 9a is minus a, and then plus 4 minus 10 is minus 6, then plus 6 is 0. So what we're left with is just this b minus a and then over 12. Now for this b minus a, this n is b minus a plus 1, then from here b minus a will be n minus 1. So we have this b minus a is n minus 1. So we have now our final expression for the variance, which is n plus 1 times n minus 1 over 12. So we have now derived the variance for the discrete uniform distribution. So I hope we learned a lot from this video and to the next video as well. So thank you for watching and don't forget to subscribe in my channel.